Hello everyone. Welcome to the another very important session in which we will be discussing some more important concepts and some more important tricks to solve the classical mechanics questions. Now in this video, whatever discussion we will be doing, that's going to be very much important for your upcoming exam and will be helping you a lot to take your preparation to the next level. We will be starting the discussion about all these important points soon, but before I'm going to continue the discussion, I'm going to check it out whether everything is all right and clear your side or not, and then we will be starting the discussion about all these important points which we will cover up in this session today. So let me just quickly check it out once and then I will be starting the discussion about all these important points. Okay, I hope each and everything is clear. Now, we will be starting the discussion for the important point, but before that, I would like to tell you something about the Unacademy subscription. So guys, by taking the Unacademy subscription, whether plus or iconic, you can take your preparation to a very good level under the guidance of top educators. Because we are going to have the important courses going on Unacademy by the top educators where you can learn new tricks, concepts, right approach to solve the questions and many important points. So all these things will be helping you a lot to take your preparation to the next level under the guidance of top educators. One more thing guys, right now, till today this offer is valid just till today, that means till 28th April. So if you want to take the Unacademy Plus or the Iconic subscription, then you can take the subscription now. And by using and by applying the referral code which is Anjali A Live as mentioned here on the screen, you will be able to get the 20% discount in the total Unacademy subscription amount. So you can even have a look at this, that we are going to have the regular prices for the plus subscription, these ones, for the offer prices these, and this is the amount you will save. For the plus subscription it has been shown here, then for the iconic subscription it has been shown here. So if you will be taking the iconic subscription or the plus subscription for different duration, for example 24 months, 12 months, 6 months and 3 months, then you will be able to get the subscription in this duration as it has been mentioned here for the different duration as shown here on the screen. Same for iconic and plus, clearly it has been shown. But to get the 20% discount in the total subscription amount, what you have to do, you can use and apply the referral code which is Anjali A Live as mentioned here on the screen. So by using and by applying this referral code, you will be able to get the 20% discount in the total subscription amount. I hope that's getting clear to everyone. Now one more thing I would like to make clear here, that is what are the benefits you will be getting if you will take the plus or the iconic subscription. So if you will take Unacademy Plus or the Unacademy Iconic subscription, in that case you will be getting the benefits as they have been shown here on the screen. If you will take the Plus subscription, you will get these benefits. If you will be taking the Iconic subscription, then you will get these benefits. And right now, even if you will take the subscription, then you will be getting the 20% off on all the Unacademy subscription amount. So this is how everything will be helping you a lot to take your preparation to the next level under the guidance of top educators. Still, if you are gonna have any doubt, any query, any question anywhere, like at any point, you can just mention it. At the same time, after discussing all these important points, what we will do now, we will be talking about the important tricks, concepts and the questions of classical mechanics. Okay, so guys, we will be starting that discussion at the same time now. But at any point of time, if you are gonna have any doubt anywhere, you can just mention it and I will be talking about that too. Just a second. Just a second guys. We will be start taking the questions from the important topics and the concepts of electronics now. Okay, let's consider it. So we will be talking about the first very important trick from the classical mechanics section, and that is related to the Lagrangian and the Hamiltonian dynamics. which is very popular in the classical mechanics portion, okay? And if you will get to know about the tricks I'm going to consider here, you will find it's going to be quite simple, easy, and the less time taking thing for you to convert the given Lagrangian into Hamiltonian and Hamiltonian to Lagrangian. But how? I will be telling you. I'll explain each and everything about this complete process, so that whenever you will work on these things, you will not have any kind of doubt or difficulty anywhere. Just focus on the process and you will be able to do it easily. Let's say you are having the Lagrangian given to you. But before explaining that trick, I would like to tell you something about the Lagrangian and the Hamiltonian too, so that you will have the clear idea about these topics and you will be able to relate it easily with the trick. Look at this Lagrangian. We will consider it as a function of generalized coordinate, generalized velocity, and time t. Clear? At the same time, the Hamiltonian is a function of generalized coordinate, generalized momentum, and time t. These are very important, because if you will not focus on this section now, you can have some kind of confusion anywhere. In the further discussion, in solving questions, you can make mistake. There are great chances for that, okay, if you will not get it clearly. So that's why it's important that you should understand this part clearly and you should have the clear idea about these things too. So we got to know Lagrangian will be a function of this coordinate, Hamiltonian this coordinate. Now what? The next thing is Lagrangian is simply something we consider as the kinetic energy minus potential energy. And the Hamiltonian we consider as the kinetic energy plus potential energy. In case if you are going to have any doubt anywhere, you can just simply mention it, but if you are getting it, that's great. Now you have to tell me one thing here, if you know and if you can relate it, that how you will write the kinetic energy in terms of generalized coordinate, velocity, or time t. What is the general most popular common expression which we generally use? What is that to write the kinetic energy? It is simply half mv squared. That is the kinetic energy, okay, in terms of generalized velocity. So half mv squared minus potential energy. Clear? At the same time, if I'm gonna ask the same question for this part, that is the Hamiltonian related, so then you have to write the kinetic energy in terms of generalized coordinate, momentum, or time t. So what it will be? Then you will use the formula which is going to be p square upon 2m plus potential energy as it is. Clear? This is, I think, is clear to everyone. So in general, you got to know that Lagrangian is kinetic energy minus potential energy and Hamiltonian is kinetic energy plus potential energy. And what are the corresponding kinetic energy expressions which you can consider? That's even something I have considered in both the cases. Now what? Now, when you will be having, let's say anytime the Lagrangian expression is given to you, okay, I'll be taking the example from the previous year question papers. I'll be taking some of the questions from there to make it clear to you. So now, let's say some Lagrangian expression is given to you. So when the Lagrangian expression is given to you, what will happen in that case? In that case, when you will be comparing that Lagrangian expression, or if it is possible for you to compare, actually in the cases when it's possible for you to identify the kinetic energy and the potential energy terms separately, then what you have to do, you will be considering it as, after comparing the kinetic energy with half mv square, whatever m term you will get now, let's say you have to convert it to Hamiltonian now. After you had the Lagrangian part given to you, you have to write the Hamiltonian with the help of that. Clear? So you got to know about m after comparing the given kinetic energy with half mv square, and then potential energy separately you are getting to know about it. So you got to know about the m. Okay. Next thing. Now you want to write the Hamiltonian expression. What you will do, p square upon 2 into m you will write there. So whatever m you got after comparing with the Lagrangian expressions kinetic energy, just put it at this place. You will be able to get the Hamiltonian this way just by doing the comparison. But what is important here, the important thing is that you should be able to identify the kinetic and the potential energy terms separately. Only then you will be doing this thing, only then you will be following this process to write the Hamiltonian from the given Lagrangian. What about the next thing? The next thing is that once you are going to have this part, okay, you got to know how to do the conversion. But maybe sometimes it's going to be confusing for us to identify the separate kinetic energy term or the potential energy term, or even sometimes if we are able to identify the kinetic energy term, let's say it's not matching with this form exactly in the given Lagrangian. So then how can we do the comparison? So in that case, we will not be doing the comparison, we will not be finding the m value, or we will not be following the same process. What we will have to do in that case, we will actually be using the different formula to do the conversion from Lagrangian to Hamiltonian or Hamiltonian to Lagrangian. One more thing, anytime if you are having the Hamiltonian given to you and you can separately identify the kinetic and the potential energy parts from there, so in that case what will happen, you will consider the p square upon 2m plus potential energy. At place of m, whatever you will get now after comparing with this standard formula, you can just put it in the Lagrangian's kinetic energy part and you will be able to get your answer for the Lagrangian too. Okay, this is how you will be taking the steps and you will be able to get the answer. Vice versa condition, basically whenever it's possible for you to identify the kinetic and the potential energy terms separately, you can go for this process and you can get the answer in this way. Now let's talk about the next thing. So I was saying, when it is not possible for us to do the comparison between the kinetic and the potential energy terms, then what we will have to do? In that case, we will be using a formula which relates both the Hamiltonian and the Lagrangian. How? H is equal to summation over I Qi dot Pi minus L. This is what we are going to have. If you will consider it this way, what will happen then? So for example, you are going to have the x and y involved in any given system's expression, or you can just define the system with the two coordinates, let's say x and y, if it is given in the Cartesian coordinate system. So in that case, you can write this as x dot px plus y dot py minus L. Okay, now whatever is given to you, whether Hamiltonian or Lagrangian, just put it, and the other part which you want to find, keep it separately on one side. And in that case, what you will do next? The next thing will be, you just have to replace whatever you don't want, okay, in the expression. For example, if your expression is for Hamiltonian, you are writing, so it will be considered as a function of generalized coordinate, generalized momentum and time t. Means you don't want these velocity components there. So then you have to do one thing, you have to replace the velocity components in terms of momentum. And then you will be even replacing the velocity components present in the Lagrangian in terms of momentum, you will write them. And that's how you will be able to get the Hamiltonian. Same way, if you are finding the Lagrangian, then it should be the function of generalized coordinate, generalized velocity and time t. So this is how you have to replace those values, those coordinates which should not be present in the expression. Okay, I hope you are getting that. And one more thing get to know here, that is the Hamiltonian and Lagrangian are the two topics without which we can't solve all the questions in our exam. Okay. From the classical mechanics section, because you may be getting let's say any of the questions in such a way that somewhere in the process of getting the answer, you have to consider the Lagrangian or the Hamiltonian. Okay, and if it will be the case, then what you have to do in that case, you will have to just okay like use these formulae which we are considering here. Even along with these ones, the rest of the formulae which are important, which we may need to solve the questions related to Lagrangian and Hamiltonian, everything I'll be adding here, I'll be discussing here, so that you will not have any kind of confusion. So till now what we have covered, we have talked about this part, that how to do the conversion of Lagrangian into Hamiltonian or Hamiltonian into Lagrangian with two different processes. One is the trick, another one is the detailed process. I have discussed that. Now I am going to talk about the other point. What is that other point? That is, what are the important formulae from the Lagrangian or the Hamiltonian we need to prepare. So after covering this section now, then we will start taking the questions too. So I'm gonna make the two parts, like two partitions we will consider. One side we will write everything related to Lagrangian. Another side we will be considering everything related to Hamiltonian. Done? So what will happen in this case? When I'm going to consider all the formula related to Lagrangian here, what it will give you? So look at this. What are the points you have to consider actually? Lagrangian, first of all, you got to know L is equal to T minus P. The second thing you are going to consider, it's a function of generalized coordinate, velocity and time t. It's a like the very basic thing. Same way for Hamiltonian, you got to know that is t plus v, and it is a function of generalized coordinate, generalized momentum and time t. Other than this, if I'm going to talk about the next thing here, these are the Hamilton's and the Lagrange's equation of motion. So equation of motion is something you can't miss. You can't skip that part because that's going to be very much important. So in the case of Lagrangian, it is simply d by dt delta L upon delta Q dot minus delta L upon delta Q equal to 0. If in our system we will have more than one coordinate present, then for one and the other coordinate we will be writing the equation of motion separately. For example, there is x, there is y too. So for x you can write it once, that will be for x, equation of motion for x coordinate, and then you will write it for y too, and that will be the equation of motion for the y coordinate. So this is now Lagrange's equation of motion, which is also known as Euler-Lagrange's equation of motion. Very good afternoon, Soyam. Done. Other than that, if I'm going to talk about the Hamiltonian, so we are also going to have the Hamilton's equation of motion. What are these ones? Q dot, which is simply dq upon dt. Q dot means what? The differentiation with respect to t. And P dot, which is dp upon dt. So that is equal to what? Delta H upon delta P and minus delta H upon delta Q. This is what you will have. Done? Delta H upon delta P and minus delta H upon delta Q. See, to memorize the Hamilton's equation of motion, I will be sharing a trick too, so that you will not get confused about the sign positive and the negative sign when to take it. So actually, look at this situation. I'm going to give you a position, particular position, and I'm asking you to find the momentum at this position. It's a direct question. This is the position, find the momentum here. Okay, at the same time. So that is what I have mentioned, some position coordinate first of all and the momentum later on. So positive aspect. Why positive? Because I will be comparing it with the other part. What is the other part? The other part is when we are going to have the momentum. Okay, for example, somewhere the momentum is given to you. Clear? When the momentum is given to you somewhere and now in the whole universe, means it can be at any point in the whole universe, you have to check it out what is that point where this momentum will be existing. Okay, so this is the other situation. Now I hope you got the point. Now when you are having the momentum value given to you and you want or you need to check it out that at which position, at what point this momentum will be existing. So it's a very much time taking task because you have to search, you have to go for different positions and you have to check it out. Is it existing here? Is it existing here? So if you will compare both the situations, you will find that it is still the positive one, like having its positive aspect because you know about the position where just you have to find the momentum. But here you are having the momentum term written first of all, which is exactly the P dot, and you can simply write it as dp upon dt. And the position you will be getting later on somewhere. So it's a negative aspect. This is how you can memorize it, and when you will be considering it in this manner now, you will never ever make any mistake in using the formula or using it in a correct way. So these were something important till now. Other thing, in the Lagrangian dynamics, we are having the generalized momentum formula, that is delta L upon delta Q dot. Generalized momentum is what? That's going to be delta L upon delta Q dot. P is equal to delta L upon delta Q dot. Means depending on the coordinates present in the expression, once again, if you will say for x component you want to find it, so delta L upon delta x dot. If for y, delta L upon delta y dot. If for theta, delta L upon delta theta dot. In different questions, different coordinates can be involved, and this is how you will be able to get your answer for different coordinates and different points. I hope that's clear. At the same time, if I'm going to talk about the next point related to Lagrangian dynamics or the Hamiltonian dynamics, one by one I'll keep on considering. So in case of Lagrangian dynamics, few more things you need to know. The next thing is, if Lagrangian does not depend on time explicitly. Explicitly means what? Explicitly means the time t, actually directly the time t is not present in that expression. So if it is there in that expression, you will say, oh, it depends on time t explicitly. Explicitly it is dependent on time t. But if time t is not present there, then means actually directly t. Okay, it doesn't mean that it is as q dot it's there or something like that. No, but actual time t term should be there. If it is there, it's explicit dependency. If it is not there, it's not explicitly dependent. So if Lagrangian does not depend on time explicitly, we can directly say that the energy of that system, or for which you have taken the Lagrangian and you have mentioned it, the energy will be conserved for that case. This is a fact, this is a point which can help you to know in easy way that when the energy of any given system will be conserved and when it will not be. At the same time, when energy is conserved, then you can even say that Hamiltonian of the system is gonna be like showing the total energy. Okay, Hamiltonian is representing the total energy at the same time. One more thing, if the potential does not depend on the velocity component, okay, in Hamiltonian, so in that case also you can say it's representing the total energy of the system. Hamiltonian is representing the total energy of the system, or time dependency you can observe there too. One more thing, guys, once you got to know about these things, there is one more concept related to Lagrangian you need to know. What is that? That is the concept of action. You may have heard about the least action principle. So action is there. The action is actually what? That is the time integral of Lagrangian. So L dt, the time integral of Lagrangian is what? That's going to be the action. It represents the action. Okay. Now, you may be getting sometimes the questions based on it, and you have to use this formula to get its answer. At the same time, related to Lagrangian, one more point I would like to introduce is related to the presence of coordinates. For example, if you are going to have the derivative of any of the coordinates present in the Lagrangian. So let's say Lagrangian is there and the q dot is present in the Lagrangian, but q is not present there. So you can say that q is cyclic or ignorable coordinate, which means that its corresponding linear momentum will be conserved or constant of motion. Okay, if it is cyclic or it is ignorable. This is how you will be able to know about it exactly, that when it is gonna be the like conserved quantity or constant of motion in terms of linear momentum. In case if you are gonna have any doubt or difficulty anywhere, you can just mention it. Along with these points, let's talk about some of the points in the Hamiltonian section too. So mainly, guys, there is a concept of Poisson bracket. As we are going to have the concept of Poisson bracket, I would like to explain it first before I'm going to proceed further. So, Poisson bracket of any two functions. If they are just dependent on one variable, okay, or one coordinate, then you will write it the way how I'm going to write it. If it is dependent on more than one variable, whether in A or B or just in any one of them, okay, you are going to have more than one variables or the coordinates present. In that case, by taking a plus sign in between, you can write the same expression for the other coordinates too. Okay, so same way, but once you will prepare the one particular expression, it will be easy for you to consider it for any other case. So it's gonna be delta A upon delta Q into delta B upon delta P minus delta A upon delta P and delta B upon delta Q. This is how you will be having this expression. Done. This is what? This is the Poisson bracket of A and P. Now, what are the things you need to observe here so that you will not make any mistake in writing the Poisson bracket expression? So, the first thing you have to observe here is, you can see I have noted down the first functions derivative, that is the first order differentiation with respect to generalized coordinate. The second one with respect to generalized momentum. Then I have interchanged the denominator part but kept the numerators at the same place. So it's going to be minus sign in between I have taken. This is how we are going to represent it. I hope that's clear to everyone, but in case if you're going to have any doubt, you can surely tell me about it and we will be trying to consider that point too. Okay. So QP, PQ, but the numerators are at the same place and the sign in between has been changed. So I was saying that if A and B are dependent on more than one variable or the coordinates, so this one you will write completely for x, px means x, momentum, x component of momentum. Same way, x. But if it is also dependent on y, so plus sign and same expression you will repeat for y and py terms. Okay, this is how you are going to write it, and that's the whole process to consider the Poisson bracket. Now, why we were talking about the Poisson bracket concept here? Because we are going to talk about the next thing which will be helping you, like where the Poisson bracket will be helping you to proceed further for the simplification part. Now, what is that thing? I'll be talking about it. Look at this. If I am going to consider the next point here, that is simply, look at this, the dA by dt, total time derivative of any function, that will be Poisson bracket of A with H is the Hamiltonian there, plus delta A upon delta T. Plus delta A upon delta T. So Poisson bracket of A with H you have to consider, and you have to take plus delta A upon delta T. Please tell me in case if there is any doubt anybody is gonna have. I'll be considering it then. But if everything is clear, that's great. And we will be talking about the next thing after that. Just a second, guys. Okay, just mention in case if you are gonna have any doubt. No doubt? Okay, that's great. Let's talk about it now. So once you have considered this much part, you can see anytime if you have to find the total time derivative of any given function, in that case, what will happen? You will be considering it this way, that is the Poisson bracket of A with H plus delta A upon delta T. And now if I'm going to talk about anything like which is a constant of motion or a conserved quantity. So in that case, you will be taking the Poisson bracket of that function with the Hamiltonian and you will say it's going to be equal to 0. Okay, because that is a constant of motion or a conserved quantity. So that's how you will be able to get the condition for the conserved quantity or constant of motion here as well. In case if you are going to find something is not clear to you or somewhere you are going to have any doubt, surely mention it. I'll be trying to consider that too. Otherwise, what we will do now, we will be starting to consider the important questions and the concepts related to the Lagrangian and the Hamiltonian dynamics. Okay, so I will be starting the discussion about these important questions now. Let me know in case if you are going to have any doubt anywhere. Just a second. And if everything is clear, that's great. That means we can continue the discussion about the important questions now. Done? Okay. Now, whatever discussion we have done till now, you will be using it to solve the questions. Okay, and how you will apply those concepts in solving the questions, you will just observe it with this further discussion. If the Lagrangian of a particle moving in one dimension is given by L is equal to x dot square upon 2x minus Vx minus Vx, then the Hamiltonian is. This is the question. And the options have been given as half xp square plus Vx, then x dot square upon 2x plus Vx, then we are going to have half x dot square plus Vx, and the next one is p square upon 2x plus Vx. Try it now and let me know what will be the right answer according to you. I'll be considering it then. Done? So let me know what is the right answer according to you for this question. Just a second. And as you will be getting the answer, you can just mention it in the comments, whatever is the right one. And if you will not be getting it, I'll explain it then. Check it out once. I'm just going to check out your comments too. Whether you are going to get the right answer or not. Whatever you are getting or whatever should be the correct one according to you, you can mention it in the comments. Clear? But till now, no such comment is there. So just in some time, I'll be starting the discussion as well. Okay guys, I think we should start the discussion now. Clear? Look at this. If I'm going to talk about this question now, you can see they have given if the Lagrangian of a particle moving in one dimension is given by, that is L is equal to x dot square upon 2x minus Vx. So it is what? It is just exactly the kinetic energy and the potential energy term. You can get it clearly that which one is the kinetic energy term and which one is the potential energy term. It's getting clear from here. There is no such confusion or doubt. So what we can do, we can write it simply as half mv square minus potential energy. Done. When I'm comparing it with half mv square, at place of m, I'm getting 1 upon x. At place of m, I'm getting 1 upon x. Done. So what I have to do now, I need to write the Hamiltonian. So what is the Hamiltonian? Hamiltonian is actually the kinetic energy plus potential energy. And since we know Hamiltonian can just be a function of x or p, okay, so in that case, what will happen? So since Hamiltonian can be a function of generalized coordinate, generalized momentum and time t, so we are just going to write kinetic energy plus potential energy, where kinetic energy is p square upon 2m. So you will get p square x upon 2 plus v. Where is p square x upon 2 plus v? That is option A, and that is your correct option. So you can see how I have taken the steps to get the answer for this question. In case still if you are gonna have any doubt, any confusion, anything which is not thing I'm not getting, or somewhere you are gonna have any question, any query, any doubt, then just mention it and I will be considering that too. Done? And if it is clear, that means we can take the next question here. you have to find the Poisson bracket of magnitude of vector r with magnitude of vector p, and the options have been given like magnitude of vector r, magnitude of vector p, then option B is unit vector r dot unit vector p, option C is 3, option D is 1. Since I have explained the Poisson bracket concept and you know what are the general coordinates we are showing here, so you can simply find the answer for this question and you can get it what it is gonna be, and just mention it in the comments if you are getting the right answer. If you will not be getting it or if you don't know how to find it, then just in some time I'll start the discussion about this question's answer. Okay, but still I just want you to try to solve this question. Try it once, and if you're gonna get the right answer, you can mention it in the comments too. Okay guys, vector r here is representing the position vector whose magnitude, because you can see they have shown you the magnitude, that is going to be x square within the square root plus y square plus z square, because vector r is x I cap plus y j cap plus z k cap. So square root x square plus y square plus z square. At the same time, magnitude of vector p is what? Px I cap plus py j cap plus pz k cap. So px square plus py square plus pz square. This is what you will have. And you have to find the Poisson bracket of this complete expression. Since you know the Poisson bracket formula, what you have to do in this case? You have to consider it this way. That's going to be the first function, partial differentiation with respect to the generalized coordinate. What it will give you? Look at this. It will be giving you delta A. For example, it is A and it is B. So delta A upon delta X, delta B upon delta PX. Delta minus delta A upon delta PX and delta B upon delta X. Plus, that's going to be delta A upon delta Y, delta B upon delta PY. Minus delta A upon delta PY, delta B upon delta Y. Okay, plus delta A upon delta Z, delta B upon delta PZ. Minus delta A upon delta PZ, delta B upon delta Z. This is how you are going to write all the terms. And this is how you will be able to get the correct expression for any such case. Done? Now, when you will be differentiating the A means square root x square plus y square plus z square in this case, what you will get? You can say it is x to the power half form, like capital X, if I will say it's power half. So which will give you nx n minus 1, which is minus half. Okay. So minus half you will get in the power. So it will be giving you 1 upon 2. And then square root of all the terms present here, x square plus y square plus z square. Okay, this is how you will be able to write it. One more thing, 2x will be in the numerator because you have to differentiate the complete expression once again, which will give you 2x. Same way, so you got 2x upon, that's gonna be square root and 2 in at this place, so it will get cancelled out. Into you will get px and then square root of p terms. Okay, same way if you will check out the other terms, you will find for the delta A upon delta px, there is no px term, it's the partial differentiation, it will give you 0. Just first terms are giving you some non-zero value. Other than that, the second complete term after the minus sign will be giving you the 0 value. So in this case, again you will get py upon square root x square plus y square plus z square. The second, this derivative will give you py upon square root px square plus py square plus pz square. At the same time, here you will be getting z upon square root x square plus y square, same way, okay, same terms. So you can write or consider these terms as, look at this, x I cap plus y j cap plus z k cap, and then px I cap, then you can consider py j cap, and then you can consider pz k cap. Done. Once you are going to consider it in the denominator also, you are having the product of x square plus y square plus z square. At the same time, on the other hand, you will have px square plus py square plus pz square. So what it is? It is simply the r, vector r upon mod r, vector p upon mod p, that is unit vector r dot unit vector p. Where it is going to be there at option B, hence option B is the correct one. This is how you are going to get it, okay? This is the whole process you have to follow to get the answer. In case anywhere still, if you are going to have any doubt, just mention it. I'm just going to show you the complete slide together and tell me if everything is clear or not. I hope it's clear now. Done. Check it out and mention in case if you will have any doubt anywhere. And if everything is clear, that's great. Clear? Just have a look at this and mention if there is even a single point or just anything which is not clear to you, mention it then. And if everything is clear, that's great. That means we can take the next question now. Let me know, guys, if something is not clear to you. Let me just take the next question, okay? And wherever you will have any doubt, mention it in the comments. I'll be talking about it then. Okay, let's talk about the next point now. That is the next question. A system is governed by the Hamiltonian and px py are momenta conjugate. To x and y respectively. To respectively. For what values of A and B will the quantities px minus 3y and py plus 2x. Be conserved. Be conserved. Options are A is equal to -3, B is equal to 2, A is equal to 3, and B is equal to -2. A is equal to 2 and B is equal to -3. Next is A is equal to -2 and B is equal to 3. Just tell me once you will get it done, or you are going to get the right answer for this question, that what it is. You can mention it in the comments too, and if you're not going to get it, then I'll be discussing it as well. So check it out, check it out, check it out. What should be the right answer? Very good afternoon, Sachin. Clear? And tell me as you are going to get the right answer for this question. Try, and let me know as you will get it done. What should be the right answer according to you for this question? And all the questions which I'm discussing and taking here in the session are mostly from the previous year CSIR NET exam. Okay. If anybody is going to get the answer for this question, just mention it, whatever is the right option according to you. I will be talking about that too. Even if it is right or wrong, we will consider it then. Check it out. Check. Let me know as you will get it done. Tell me. Done? Clear? Okay, still nobody has mentioned the right answer. We'll be waiting for the right answer and then we will be starting the discussion too. Done? Okay, let's talk about it, guys. Exactly what they have given you. They have mentioned a system is governed by the Hamiltonian, which is gonna be this Hamiltonian, where A and B are constants and Px and Py are momenta conjugate to x and y respectively. For what values of A and B will the quantities Px minus 3y and Py plus 2x be conserved? Now, I have told you one thing when I was doing the discussion about the Hamiltonian and Lagrangian just before the giving you the questions. So then I have talked about one thing, the Poisson bracket of any function with the Hamiltonian, if it is 0. So it means that function is a conserved like 1 or the constant of motion. Same concept you have to relate here. This is the function, you have to take its Poisson bracket with the Hamiltonian. And when you will equate it with 0, because why you will equate it with 0? Because they have mentioned it's a conserved, like this and this, these quantities are conserved. So Px minus 3y, comma, what is the Hamiltonian here? The Hamiltonian is half Px minus ay square, half Px minus ay square. And other than that, you are going to have plus half Px minus Bx square plus half what they have given? Px, oh, did they provide us both Px? So it should be Px minus By. Let me just check it out once. Clear? In case even if you had any confusion, you can mention it. So Px minus 3, okay, Px minus Ay, and it should be Py minus Bx. Already Px is there, so this should be Py. Now it's correct. Otherwise, it was not giving us the same form. You can even check it out if you had any confusion. This form and this form, this form and this form. Okay, you will get to know that whether px minus ay, so px minus 3y, py minus bx, so py plus 2x. So y and x together, x and y together, this way you can take it. If you were even having any kind of confusion, you can mention it this way. Now what is the expression? Py minus bx square, py minus bx square. This is the Poisson bracket you have to consider here at this place. Okay, let's proceed further to find the Poisson bracket. Let's equate it with 0 because it's the constant of motion or the concept quantity case. Now, first function partial differentiation with respect to x0. Second one with respect to px, that will give you something from here, which will be half, like 0 into anything is 0 now, so anything. Minus first function with respect to px1, second one with respect to x. What it will give you? Py minus bx, then minus b. So minus b is equal to what? 0. So from here, are you going to get some value? Let me just talk about it once. You will get one more thing here. What is that? That is simply, let's consider it once again, guys. First function partial differentiation with respect to x0. Second one with respect to px will give us something. First one with respect to like px1. Second one with respect to x, that will give you 2 py minus b, py minus b x, okay, and then minus b equal to what? It's gonna be 0. This is the expression you will have. At the same time, if I will talk about the next thing here, what is that? The next expression. What is that? Py minus 3y, okay, plus, right now I have just mentioned it for x. So y term is even there. So I have to take further more terms in this expression. What it will be? Plus sign. First term partial differentiation with respect to y, minus 3. Second one partial differentiation with respect to py. What I will get from here? I will get py minus bx minus first term partial differentiation with respect to py, 0. So I don't need to write that. It is equal to 0. Now it is the complete expression. Earlier, I have just taken the differentiation with respect to x coordinates, not y. But if you will write it completely, as you can see, x and y both are involved there, you will get this expression. Let's take the py minus bx common and minus sign common. So you will get b plus 3 equal to 0, which is b is equal to minus 3. You can even check out the sign. If you are going to get something else here, you can check it out. Is it going to be present in the expression somewhere or not? Okay. So check out the sign. Oh, it's gonna be minus minus plus, guys. So when it is plus, so it is plus b, but that is minus 3. So b minus 3 equal to 0 you will have. When it is b minus 3 equal to 0, you will get b is equal to 3. So b is equal to 3 we got. At the same time, we also have to check out the second function, that is py plus 2x. So when I will go for py plus 2x, because Hamiltonian will remain same, so what I will do, I will be making the changes in the same expression. So I'm just going to remove this calculation part from here and I will have to make changes py plus 2x plus 2x. Next thing, if I'm going to talk about the first function, you have to differentiate it with respect to x first of all, what you will get to. Second one with respect to px, that will give you px minus ay, then minus sign. First one with respect to px, 0. Okay, this is for x coordinate, plus first one with respect to y, 0, and second one anything, 0, minus. It's gonna be first one with respect to py, 1, second one with respect to y, that will give you px minus ay and minus a. So minus a, px minus ay. And this is gonna be equal to 0. Okay, if you will simplify this part, what will happen? You can take the px minus ay common. What it will give you? It will give you 2 minus minus plus a equal to 0. A is equal to what? Minus 2 you will get. So a is equal to minus 2 is something you are getting, and you have already got, this was from here, no? I think it's from here. Yep. So we have got A is equal to -2 and B is equal to 3, which is there in option D, and that is the correct option. In case if there is any doubt anybody is gonna have here at any point, just mention it. Let me know about it. We will be trying to consider that too. And if everything is clear, that's great. Okay. But at any point, if you are gonna find like, oh, something is not clear to you, or somewhere you are gonna have any doubt, just mention it at the same time. Okay. Guys, if it is clear, what we will do, we'll be taking one more question right now, and then just in some time we will be ending this session. Done? So let's take one more question, let's solve it, and then we are going to consider these many points in this session today. Let me just give you one more related to the discussion we have done in the session in the starting. Okay, one more question which I will be giving you is a general concept based question, not just from the Hamiltonian or Lagrangian. It's a general concept. How you will solve it? Let's say the question is, a particle moves in two dimensions on the ellipse. The equation for that has been given to us, which is x square plus 4y square is equal to 8. At a particular instant, it is at the point xy is equal to 2, 1, x comma y is equal to 2, 1, and the x component of its velocity is 6 in suitable units, then the y component of its velocity is of its velocity is. Options are -3, -2, 1, 4. Please tell me in case if you will have any doubt anywhere. Try it now and mention the right option, whatever is the correct one according to you. If you will not be getting it, I'll be explaining it then, but I hope you will get the right answer. It's a general question we are going to have. I'll give you some time to solve it, and then I'll be discussing it too. Okay guys, let me just see if anybody has answered. No. So basically, if I'm going to talk about this question, in this case they have given you x component of velocity and they are asking you to find the y component of velocity. So you will be differentiating the given equation with respect to t. It is 2x dx by dt plus 8y, okay, dy by dt. Done. Where dy by dt is vy, which is the y component of velocity, and the dx by dt is the x component of velocity. X and y coordinates are going to have the values 2 and 1. So 2 and 1 means 2 2s are 4, and dx by dt x component of velocity was 6. So 6 plus 8 1s are 8, vy, which is the y component of velocity. So vy is equal to what? 24 with a negative sign upon 8. So that will be minus 3. Where you are going to have minus 3? It's an option A, and that's your correct option. So you can see how you will proceed further to solve this question. In case still if there is any doubt anybody is going to have, just mention it. Let me know about it and we will try to consider that too. And if everything is clear, that's great. This is how you have to take the steps and you will be getting the answer for any such type of questions. Okay guys, I hope each and everything is clear to every one of you. But in case if you are finding any point, anything which is not clear to you, you can just mention it then. So we will be keeping it this much right now in the session. If you want to attend the regular live classes by the top educators we are having on Unacademy for your upcoming exam preparation, in that case you can take the Unacademy Plus or the Iconic subscription. And since till today there is an offer which is valid on the Unacademy subscription, so if you want to grab this offer, you can take the subscription today because it is valid till 28th April. By using and by applying the referral code which is Anjali A Live as mentioned here on the screen, you will get the 20% discount in the total Unacademy subscription amount as per this offer. The prices after the discount, the amount you will save, the regular prices, all that have been shown here on this slide too. So depending on this thing, which one you find more beneficial, whether Plus or the Iconic subscription, you can take that subscription and start your preparation under the guidance of top educators. Take your preparation to a very good level this way. So I hope each and everything what I have discussed in the session will be clear. And even if you want to learn new tricks, concepts, right approach to solve the questions and many important points under the guidance of top educators, then you can take the Unacademy Plus or the Iconic subscription and use and apply the referral code which is Anjali A Live as mentioned here on the screen. And by applying the referral code, if you will be taking the subscription today on 28th April, you will be getting the 20% discount in the total subscription amount. Let's keep it this much right now in the session, guys. And thank you so much everyone for joining this session and for attending it till the end.